Hi, my name is Kayla Jarvis from the University of Texas at Austin, and welcome to Pirate Math Equation Quest Word Problem Intervention with total, difference, change, and equal groups. In this video, we'll be reviewing the equal groups schema. Our intervention has 5 components: captain cards, equation quest, Buccaneer problems, ship-shape sorting, and Jolly Roger review. Our students solve equal groups problems in Buccaneer problems and Jolly Roger review. For the purposes of this video, we'll be reviewing equal groups problems within the context of our Buccaneer problems intervention component. For this activity, you will need the large schema mat, version 4 to include all 4 schemas, a Buccaneer problem, a pencil, and the What Do You Ask Yourself poster. There are 4 schemas: total, difference, change, and equal groups. In equal groups problems, we have groups with the same number in each group. Reviewing the gestures helps cement the schema instruction into students' brains. We have groups with the same number in each group. We're going to review 3 different equal groups problems. One where the product is missing, one where a number in each group is missing, and an area problem. This is our equal group poster. In step 1, we write GR times N equals P, where GR is the number of groups, the N is the number in each group, and the P is the product. In step 2, students will identify P, the product. In step 3, students will find the groups and the number in each group. In step 4, they will write the signs for their equation. And in step 5, they will solve for the unknown. Let's look at a problem where the product is missing. Here we have a word problem. My first step is to check and see if there's a table or a graph. There is no table or a graph, so I can go straight to my UPS check squared attack strategy. I've written UU, PP, SS, check, and check. Our first U stands for understand by reading, so let's read. A classroom has 6 rows of chairs with 11 chairs in each row. How many chairs are in the classroom? I can check off my first U because I understood by reading. Our second U stands for underline the label. Our label is typically in our question sentence. Our question sentence says, how many chairs are in the classroom? I know this question sentence is about chairs, so I'm going to underline chairs. And check off my second letter U. Our first P stands for parentheses and needed numbers. So we're going to put parentheses around our 6, because we have 6 rows of chairs, and around our 11. And let's go all the way around to get those chairs in each row. And check off our letter P. Our second letter P stands for put numbers in order. This is a single-step equal groups problem, so this is pretty easy because they're both going to be in the same step. I'm going to put a 1 on top of our 6 rows of chairs and a 1 here on top of our 11 chairs in each row. And I'm going to check off my second letter P so I know I'm done with that step. Our first S stands for schema. I know that there are groups with an equal number of in each group in this problem. So this is an equal groups problem, and it's a single step one. So I can put 1, e.g., and circle it to keep it organized. And check off my first letter S. My second letter S stands for set up and solve. So I can follow the steps on my equal groups poster. Step 1, we're going to write GR times N equals P. And for step 2, I'm going to identify the product. So they're asking how many chairs are in the classroom. That's going to be our total amount of chairs here. We don't know our product in this situation, so I'm going to put a blank underneath. For the next step, we need to find the groups and the amount in each group. I know that we have 6 rows of chairs. Those rows are going to be my group, so I'm going to put that underneath here. I know that I have 11 chairs in each row, so that's my number in each group. I'm going to put that underneath my n. Now I need to populate with my signs. And I have 6 times 11 equals blank. I can do the mental math here. I know that 6 times 11 is 66. But I'm not done yet. 66 what? Well, we underlined our label earlier. Our label is chairs. So I put chairs here. And now I've solved, I can check this off and I can check for reasonableness. I know that 6 times 11 is 66 and I've got my label. So this one is done. Here is an example of a student-worked word problem featuring an equal group schema. You can see they identified that it was an equal group schema and put EG to the side, that they used the equation GR times N equals P, that they identified the groups and the number in each group, and they put an X for the product. You can use a blank space if the X is confusing with the multiplication sign as well. Now let's take a look at a problem where a number in each group is missing. Here I have a word problem, and my first step is to look for a table or a graph. If I saw a table or a graph, I would number it. But since I don't, I can go straight to my UPS check squared attack strategy. I'm writing U, P, P, S, S, check, and check. Our first letter U stands for understand by reading, so let's read. Miss Lasoya has 72 starbursts. She will arrange the starbursts in 6 equal stacks. How many starbursts will be in each stack? We read the problem, we understood by reading, let's check that off. Our second letter U stands for underline the label. Our label is typically in our question sentence, so let's look there. How many starbursts will be in each stack? I know this problem's about starburst, which sounds so good. So let's underline starbursts and give that a check mark. Our first P stands for parentheses and needed numbers. So I'm scanning through the problem. I'm seeing we've got 72 starbursts. That applies to our label. My favorite are the pink ones. And she will arrange the starbursts in 6 equal stacks. We've got 6 equal stacks as well. And we check off that letter P. Our second letter P stands for put our numbers in order. This is still a single step problem, so I can put a 1 on top of each of these. And give this a check mark. Our first S stands for schema, so students can use the what do you ask yourself poster here. Are there groups with an equal number in each group? Here we have 72 starbursts, and Miss Lasoya is going to put them into 6 equal stacks. Those sound like equal groups to me, so this is a single step equal groups problem. I can put a 1 for single step, and an EG for equal groups, and circle it just to keep myself organized. And I can check off this first letter S. Our second letter S stands for set up and solve. Students can use the equal groups poster or use it less and less as you go through the lessons. Hopefully they have it in their brain. We've got GR times N equals P. And so first, we're looking for that product. In this one, we have Miss Lasoya has 72 starbursts. She doesn't have any more than that, and we're dealing with whole numbers. So we know that 72 is our product. I'm going to put that right under the letter P. So now I'm going to look for groups and number in each group. She will arrange the starbursts in 6 equal stacks. Those stacks are going to be our groups. So I'm going to put 6 underneath GR. Do we know the number in each group, or is that what they're asking for us? That's what they're asking from us. So I'm going to put a blank right here and I'm going to populate with our signs. So now I have 6 times blank equals 72. Students could do the long division for this one, but I know my 12 times tables and I know that 6 times 12 is 72. So I'm going to put 12, and I'm not done yet. Need to check off my S for solve, and I need my label answer here. We always have a number answer and a label answer. I underlined starbursts earlier, so I'm going to put starbursts. And now I check my answer for reasonableness. Students could use a multiplication table to check their answer if they wanted for this type of problem. I don't need to. I know that 6 times 12 is 72, and I know that starbursts matches the label in our problem. So this one is complete. Here we can see a student's worked example of an equal groups problem. They identified the problem as equal groups and put it EG with a circle around it to keep them organized. They've put down GR times N equals P. They have placed 4 under GR and then 20 under the product, and they identified that N was their unknown, the number in each group. And you can see that they have a number answer and a label answer. They didn't use UPS check squared for this one. They used a different attack strategy, but you can see that they checked off each individual step to keep them organized in that process. Now let's take a look at an area problem. Here we have a word problem. My first step is always to check for a table or a graph. I don't see one here. If I did, I would number it. Now I can go straight to UPS check squared. I'm writing U, P, P, S, S, check, check. Ooh, squeaky. Our first U stands for understand by reading. So let's read. Juliet's picture frame has a length of 25 centimeters and a width of 4 centimeters. What is the area of the picture frame in square centimeters? I can check off my letter U because I understood by reading. My second letter U stands for underline the label. The label is typically in my question sentence. It's asking me, what is the area of the picture frame in square centimeters? Now I know something about area, and I know that it happens to be in square units. So that square centimeters is going to be my label for this problem. Oh, it's singing to us. And now we're on step P for parentheses and needed numbers. Now we have our length and we have our width, and those are the ones that we need for area of a quadrilateral. So we're going to put a parenthesis around here, our 25. Ooh. And centimeters. Sorry about that. Didn't want to leave you. And a width of 4 centimeters. There we go. And we're checking off the letter P. Our second P stands for put numbers in order. This is a single-step equal groups area problem, so I'm going to put a 1 on top of each one of these. And check off the letter P. Our first S stands for schema. We need to identify the schema here. Now, if this was perimeter, it would be a total problem. But since it's area, I know that my width is going to represent groups and my length is going to represent the number in each group. And we can think of those as columns and rows for our square units. So I can put a 1 and an EG for equal groups. And check off my letter S. And my second S stands for setup and solve. So I'm going to use my equation, GR times N equals P. Now here my product would be the area, but it's asking me what the product is in our question sentence. So we don't know it. I can put a blank underneath it. Now I'm looking for my groups and my number in each group. Now I know that we have a width of 25 and a length of 4. So I'm going to put 25 under my groups and 4 under the number in each group. Could you switch these? Absolutely. Now I'm going to plug in my signs, and I have 25 times 4 is blank. So I can, oh, not yet. So I know my mental math, and specifically, I know that quarters are 25 cents and 4 quarters are in $1. So 25 times 4 is going to give me 100. So I can put 100 here. And I'm not done yet. 100 what? Well, we underlined square centimeters earlier, so you could have students write out that whole thing, or you could tell them the shorthand shortcut of centimeters squared, and both would be fine in this instance. And we can check off that letter S, and now I need to check my answer for reasonableness. I know that 25 times 4 is 100. I could double check with the algorithm, but I don't have to. And I know that centimeters squared matches area problems. So this one is done. This is a student work example of an area problem. You can see that students have the lengths and each unit delineated here in the picture. You can see that they identified this problem as an equal groups problem, and that they used the GR times N equals P equation, that they identified that their unknown was the product, and that they have their answer in square units. Thank you for watching this video on equal groups problems. We would like to thank the Institute of Education Sciences, the University of Texas at Austin College of Education, and the Meadows Center for Preventing Educational Risk. Without their support, this research would not be possible. Thank you, and see you in the next video.